Hey everyone, welcome to Code Harmony. Today we are going to solve this LeetCode challenge 3223, minimum length of string after operations. This is a string based question and asked in Bloomberg. Let me explain the problem statement to you with the help of an example. Here every problem has mainly three sections, like what is given to us, what operation we have to perform, and what is expected from us. So what is given here? Given is a string which can have length from 1 to 2 at 2 into 10 power 5. This is the length, and this string is only containing lowercase English letters. Okay, so this is given is a string, and what operation we have to perform? Let's say we are picking any character I from this string, such that there should be one character in the left and one character in the right with the same value. Let's say at index I we have a character A, then there must be character A on the left side, character A on the right side, and the operation is that we have to delete this character and this character, nearest character. Let's say the string is given to us as let's say the string is having these 4 A characters. If I pick this A as my ith character, then there is one A on the left side which is the nearest one, this one, and one A on the right side. So in one operation, what I can do is I can delete this character and delete this character from the string. So this is my operation. And after one operation, what is the remaining string? Remaining string is this A and A, this A and this A. So the string length has reduced from 4 to 2. So this is my operation. This is also written in the problem statement. Choose any index I such that there is at least one character to the left of I which is equal to s of I, and at least one character to the right which is equal to s of I. If we have chosen this ith index, then what we can do is delete the closest character on the left and closest character on the right. So this is our operation, and after n number of operation, apply the operation as many number of times you want whenever you are keep getting I, and in the end what you can return the minimum length of final string. So let's say in this case we have reduced our string from 4 times A to 2 times A. Can we further reduce it? Let's say I am picking this as my ith character. There is one A on the left but there is no A on the right. Let me give you a bigger example. Let's say my string is something like this: A, and A. Okay, let's say in this case I choose this middle A as my ith character. Then there is one character on the left which is closest to A with the same value, and there is one more character on the right with the same value. So we can delete these two characters because this is our operation. And still after this operation I can apply one more operation. This character and this character is same as my ith character. I can delete these two characters as well. So ultimately my string has reduced to just one character, which is A. So now come to the problem statement. Given is just a string, and operation I have explained it to you. This is the operation we have to perform. What we have to return? The length of the processed string. Let's say after the operations, this is my remaining string, and the length of the string is 1. In this case the length was 2. So this 1 and 2, this integer we have to return. And now I hope the problem statement is clear to you. Let's build our approach on this example. Here in this example, string given to us is this, and what we can do is we have to perform our operations, picking any ith character, and if I am having the same character on the left, same character on the right, I can delete those two characters. So in this case I can see there are a couple of characters which are repeating. This, if I choose E from this, I'm having 1, 2, 3, 4, 5, 6 times E in this string, and none of other characters are repeating. There is only one L, one T, one C, one O, one D. I cannot apply this operation because for this operation, let's say I'm choosing T, there should be one more T on the left side and one more T on the right side, but that is not the case. Only E is repeating. Let's extract out these E. I'm just writing E 6 times. 1, 2, 3, 4, 5, 6. Okay. Let's say from these E's, I'm choosing any ith character. Let's say that is this one. So how do I apply my operation? If I go as written in the problem statement, just pick the nearest E on the left side, nearest E on the right side. If we are able to get the nearest E on the left and right side, both sides, then we can discard those characters. Discarding character on the left side, discarding character on the right side. 2 characters we have discarded. Let's say every time we are performing this operation, discarding characters and performing a new string, then that is a very lengthy operation. And my operation says that there must be one, let's say one character is this. There should be one same character on the right side, same character on the left side. It means if there is at least 3 characters, I can definitely choose the middle one and delete both the left and right one. Because that is true, because this is the I is the index. It should be less than I, it should be greater than I, because these are the part of a string. Okay. So it's clear that if the character count, if greater than equal to 3, in that case we can reduce those characters, or we can delete those characters from the string. So firstly, let's check our 2 possibilities. If it is greater than equal to 3, if it is less than 3. If it is less than 3, either the character can be like this A, 2 times A, or it is not at all present. If it is not present, we can't do anything. If it is present only 1 time, still we cannot apply our operation, it will remain as it is. Even when it is appearing 2 times, we cannot apply our operation, it will remain as it is. We can't do anything on these characters. Okay, for the characters which are having their frequency less than 3, we can't do anything. If the frequency is greater than equal to 3, then what are the different possibilities we are having? Then what I can think of is that it can either be even or odd, something like this. Let's say it is coming, if it is even, let's say coming 4 times, 1, 2, 3, 4. Odd, it is coming 3 times. If it is 3 times, we can choose this as I and we can delete these characters, and the final string will be A. Only 1 character string. If it is coming even times, in that case, let's say if I'm choosing this A as I can delete this, I can delete this, and then ultimately we will be left with 2A. And if it is 2A, we can't do anything. So we'll be left with 2 characters in the string. Okay, what about we have many characters, more than 3 characters which are odd. Let's say if I take an example of 5 times A, 1, 2, 3, 4, 5. I think this is the same. Choosing this I as a character, ith character, and delete this and delete this, and apply the same operation again. Delete this, delete this. So whenever, now it is clear, whenever it is an odd frequency, that frequency will be reduced to 1. Okay. What about if it is even? If it is even, let's say we are having 6 times A, and 3 more times as well. If I'm choosing this I'll be able to reduce this to deleting 2 characters from this and deleting 2 more characters from this, and after the operations, these 2 characters will be there. It is reduced to double A, which is 2. So whenever it is an even frequency, I can reduce those frequency, whatever is the value. Let's say if it is 10, 20 or 100 or 10,000, I can reduce it to only 2 characters in the final string. If it is odd frequency, then I can reduce it to 1. See, it is very simple. If the frequency is even, I can reduce it to 2 characters. Frequency is odd, I can reduce it to 1. And what is the time on this operation? This is a constant operation. just checking the frequency. If you know the frequency, and how do you know the frequency? Let's say let's come to the example. Here, this is the example, and how do you know the frequency? This is given in the problem constraints that this string is going to have lowercase English characters. If it is lowercase English characters, it will go from A to Z, which is only 26 possibility. Just take an array of size 26 to capture the frequency. Let's call this array hash array. Hash array is going to capture the frequency. So the frequency will be L is coming one time, E is coming 1, 2, 3, 4, 5, 6 time, T is coming one time, C is coming one time, O is coming one time, D is coming one time. L, E, T, C, O, D. Okay. Now this is my frequency set or hashing of the frequency. This I can utilize by how do we get to know this? Just iterate over the string from I equal to 0 to n minus 1 and capture the frequency. Capture the frequency in an array of size 26. So in order of n time, I can calculate the frequency. Now this frequency is 1, it will remain 1. This frequency is even. Even, it means I can reduce this frequency to 2. All are O1, so they will remain 1. So I'm going to use this logic. If it is even frequency, I will consider only 2 in that case. If it is odd, consider 1. So what I can do is, let's write the pseudo code. S is given to us. So what I can do is, for now, I will be writing a loop from 0 to n minus 1. And I can use a hash array of size 26. A will be mapped to 0 and Z will be mapped to 25. Okay. So this is the loop, and in this loop, hash of character minus A plus plus. What is this character? This character is the ith character. Now this loop will be capturing frequency of every single character. And now you have frequency in that 26 size array. Now you can just iterate over those 26 size array. I equal to 0 to 25, both inclusive, and see if the hash of I, it means the frequency of, let's say if I equal to 0, frequency of A. If the frequency of A is greater than 3, only in that case we can do something. Otherwise, see, we have two possibilities. If the frequency is greater than 3 or greater than equal to 3. If it is greater than equal to 3, then we can see if it is even, count as 2. If it is odd, count as 1. Otherwise, like this. Or let's see whether we require this condition as well. Let's say if it is 1, 1 is odd, it means it is coming as 1. 2 is even, it is coming as 2. And what about 0? 0, we don't require this. And what about 3? 3 is odd, coming as 1. So I think we don't require this condition. So just keep it like this. If the frequency is greater than 0, if there is some frequency, then see if it is even, answer plus equal to 2. If it is odd, answer plus equal to 1. And in the end, we have to just return answer. So what I did is, firstly I captured the frequency, and capturing frequency take iteration over the complete string. And the string was going into string can go till 2 into 10 to the power 5, or let's say it is going till n. Order of n time to capture the frequency, and order of 26 is my space complexity, but that we'll just consider as a constant one. Order of n time. And now what about this? This is order of 26. This is constant. So order of n plus order of 26. And yeah, that's all. So what is the ultimate time and space complexity of this approach? Time complexity is going in the order of n. And what about the space complexity? We are not requiring any extra space because we are given lowercase English characters, and those characters will be taken care by 26 size array. So this is the final time and space complexity. Now let's code this approach. Firstly, I will be capturing frequency and then calculate my answer. To capture the frequency, I need to iterate over every single character for character ch. I can capture those characters in the hash array of size 26 because it's only lowercase English letters. Int hash equal to new int 26, and for every character ch minus a map to the right index plus plus. Now frequency is captured and I need to store my answer somewhere, which I am going to return from this function, and this answer I will be capturing on the basis of the frequency values for every frequency of this string, I less than 26, I plus plus. If the frequency is there, it means if the character is coming at least one time, then I just need to see if the frequency is even or odd. If the remainder with 2 is 0, if it is, it means it is even, and in the case of even, answer plus equal to 2, else answer plus plus. Only one time we are including that character. Let's run over sample test cases. Sample test cases are passed. I'm submitting the problem. It's submitted successfully. I hope you understood the approach. It was pretty simple. We just utilized the concept of hashing. If you have any doubt, you can comment down below. I will be happy to help. Thank you guys. Bye bye.